Today's tutorial is going to be about lists in Generator. And to switch things up, I thought we'd go into light mode for a few videos. Lists are basically arrays. I don't like the word array for Generator because Figma tends to use simpler words, and an array is not something that we use every day, but a list is. So I chose list. There are two main ways to create lists. The first one is just to create a bunch of values. For example, 1, 2, let's say 5. Over here we'll say A, B, and F. And in both cases, if we select and say combine, and then select and say combine, we get two lists. You'll see that the wires coming out are blue for a number list, yellow for a text list, it's going to be red for a shape list, and so on. There are two main things to notice about this. One is that the incoming wires are single wires because they carry single values. Two, the outgoing wires are double wires. Now this follows the pattern of some Asian languages where you form a plural of a word by just repeating the word. So a table becomes not tables, but table, table. And I found this very convenient for Generator because it conveys all the necessary information. To view the contents of a list, you add a list node. And what that does is it shows you what's inside the list. If you remove one of these, it disappears from the list as well. Another way to create lists is to use sets. We'll talk about sets in a different video, but very simply, sets are nodes that create more than one value in series. So not two values at the same time, but every time something downstream asks for a new value, the sequence in this case will give it a new value. So for an example, let's add a repeat. Let's add a list. And then we see that the first value is 0, the second is 10, 20, 30, 40, and so on. Because first it starts with 0, multiplying by 1 does nothing, so we'll ignore that. But every time the sequence multiplies and adds by a value, by some value, and then it adds 10. So if we reduce this to 1, you get it, and then let's say it starts at 1, we get 1, 2, 3, 4, 5. Notice here that the wires are dotted, and what that means is that they carry more than one value, like I said, in series. A double wire carries more than one value at the same time, and a dotted wire carries more than one value when asked for it. Here's what that means. Let's say we have a list coming out of a repeat, and then another list coming out of a repeat. You'll see that this list contains 1, 2, 3, 4, 5, and this list contains 6, 7, 8, 9, 10. That is because this one asks for 5 values and repeat obliges, and this one asks for 5 new values and again repeat obliges. If we don't want that, there's a couple of things we can do. So one is just to close the loop, and that works like this. Again, I'll talk about this in the video about loops, but very briefly, this is how it works. This now creates a closed loop. These two wires are no longer dotted, and as you can see, the list contents are the same. Another way to do this is to use a freeze node. So if you add a freeze node, once again, everything to the left of freeze no longer gives new values to the right of freeze. It just stops generation of new values. So everything coming out of here is as if I were to create a list by just inserting constants into a combine. So a list will typically be used to see the contents of what's inside a list. There's another way to do that. Let's say you're working on some larger graph and there's no list here and you don't want to create one, but you still, because let's say there's a couple of nodes that you're working with. Just for demonstration, I'm going to insert a combine in here. So this will create a list, and this will also have a list inside it. You know, it might combine two things at once or something like that. To see the contents of those quickly, here in the preferences, you can say and show tooltips list items. And then when you hover over this, you get 1, 2, 3, 4, 5. Now, this is useful sometimes, but typically it's annoying, so I turn it off, and it's off by default. Take care with using sets and repeat without looping or without freeze, because even if you know what's going on, you have to be really careful about which order you make the connection in. So for example, I connected these first, and these have 1, 2, 3, 4, 5, and then these have 6, 7, 8, 9, 10, because this asked for values after this. Now let's say I disconnect this. Now this is the only one asking, so it gets 1, 2, 3, 4, 5. Now if I go and connect this, now this one gets 6, 7, 8, 9, 10. If you're not careful, this can get confusing. Again, if you freeze the output, there's no confusion because the output's always going to be the same. But sometimes it's very useful to not do that. And I'll talk about that in the video about loops. So many nodes work on entire lists at once, like a map in JavaScript. So let's say we have this 1, 2, 3, 4, 5, and we're going to loop this or close the loop just so that these values stay the same downstream. And let's see. Let's say we wanted to multiply all of these values by 2, right? Well, we could extract each one. Multiply each one by 2. Recombine them into a list. And then when we see, I'm just going to use this, and then we see that this one, because let's use a different value. Let's use 4. So 1 and 4. So we get 2 and 8. That makes sense. But this is really cumbersome. This is a lot of nodes. There's a much easier way, which is to just take the list and plug in the simple math node directly. We multiply by 2, and then if we look at the output, we have 2, 4, 6, 8, 10. So that's a mapping operation. Now we could also do an aggregate operation. So let's say we wanted to sum all of these values. We can go into the math menu and get the complex math node, plug in the double wire. And now the list didn't auto-connect because the output of this is a single value. So now we have to go and get a number value to see what's in there, or just to use it downstream. And we have our 15, which is the result. If we multiply them all together, we get the product, or the factorial, which is 120. So you can do a bunch of other stuff with lists. Essentially, you can do most things that you can do in JavaScript. For example, let's say you have some number of values. Let's say we didn't know that it was 5, all right? And we wanted to count them. So we can say count, and we have the value of 5. For certain situations, you need it to start at base 0, so the first index is 0 instead of 1, and then you can change that here, and then the count is going to be 4. If we increase the number of repeats, it's 10, and here it's 9. Another thing you can do is contains. So for that, let me use a random node. So we'll use random, we'll say repeat, and we'll say list, just so that we can see what we're working with. All right, and let's say from between 1 and like 10, so it's more visible, and we'll generate 10 of them. So here we have 10 random values between 1 and 10. And we want to check it for, let's say, 3. So we connect a contains node. We connect a constant, in this case 3. And we get a negative result because there's no 3 in this list. Now notice that I'm using the wire from list, not from repeat. Here's what would happen if I used a wire from repeat. This is weird. This says that there's no 3, right? We can't see a 3, but this says that there is a 3. That's because this is getting a whole new list, as you can see by the dotted wire. So for example, here we know that we have 2 3 times, right? So let's delete this. And now we can see that it doesn't contain 3 because that was this old list that we had. But if we say 2, now it contains it. So like I said, be really careful with these dotted wires if you want to make sure that you're getting the same thing. Let's say we again say freeze. Now the wire is solid. And now if we say list, we get the contents of the list in this node, but also we see that it's the same list coming in because it contains 2. Now the contains node works also as an index of, for those who know JavaScript. What that means is that it shows you the first index of the found value because it contains it at index 0, and the last index because it contains it at index 5. Here, this is the last 2. But it also gives you, you can see all 3 indices. The number will change depending on how many are found. And to see them, you again can use a list node. because the result is a list. So here you have the list of indices where this value is found in this list. It looks a little complicated at first, but it really isn't. It follows the same logic as any code would when you're working with lists. And I don't really think it can get any simpler because this is a pretty involved operation. Another thing, and let's actually do this with some shapes because that'll be more visual. So let's say we have a rectangle. By the way, another UI pattern used in Generator that isn't typically used elsewhere is if you hold Shift when you create a node, the menu doesn't disappear. So you can actually go in, you know what, we're not going to get a line, and create a bunch of nodes at the same time without having the menu disappear. This can be convenient for some things. So let's say we have these 4 objects. Now I'm going to move this over here. I'm going to bring my objects over here. And I'm just going to put them in a row. It doesn't really matter. And to see what they are, I'm going to use a blue color. I'm going to plug it into the style of each of these. All right. So now we can see that we have 4 objects. There's 1, there's 2, there's 3, there's 4. And if we're to combine them into a list, we can now select one of them. So we connect a select node. This has an index. As we change the index, the output changes. Here the wire is double because it carries more than one shape. Here the wire is single because only one shape comes out after the selection. Some more stuff that you can do with lists. Let's get back another random. Let's repeat. And let's say list. No, let's say freeze. Just so that it's always the same. And we're sure of that. And then we say list, and now we see what the list is. All right, let's make it a bit longer. And let's make it from 0 to 10. So here's some random values. There's 3 6s, there's 2 2s. This is pretty nice for our examples. What if we don't need the whole list? Well, then we can take a sublist. Now, the sublist works just like a substring in JavaScript. And by default, the end is an undefined number. It's an unknown value. Now, what that does is it gives you a sublist from this index to the end. So if we add another list node and we increase the starting index, what you see is that you're only getting the end of the list. If we set a value here, for example, 6, here you see that I've indicated the inclusivity of these indices. So this one is included and this one is excluded, which means you're not going to get from 2 to 6, you're going to get from 2 to 5. So it's going to be 4 6 6 1, 4 6 6 1. There you go. What else can we do? We can filter for unique values. So we select this, we say unique. So here we have 6 unique values, and then this gives you how many there are of each value and where they are. In this case, if we connect a list, we see that it's only giving us the unique values, so it's filtered it by uniqueness. Another thing we can do is reverse a list. So to see that more clearly, we're going to use a sequence again. It's just going to be more simple. Start with 1, add 1 every time, repeat. We're just going to close the loop. And then say list. So here we have 1, 2, 3, 4, 5. If we now say reverse, and then add a list, it's 5, 4, 3, 2, 1. And by the way, this is one of those instances where you might want to use this tooltip, just because you don't then have to create a list every time. So here the contents are visible, but here you can see what the result is, 5, 4, 3, 2, 1. Now, let's say you want it to, like we selected the shapes, if you wanted to select among several lists. This is not a problem, but it's a little bit more tricky. So let's say we have a sequence. We're going to repeat that. We'll freeze it. And let's say we have a list. Then we're going to copy this. And we're going to copy it one more time. So now we have 3 lists. Here I'm going to just make some weird sequences. This one will have some multiplication. There you go. They're getting really large. All right, so now we have some different lists. Combine cannot really be used in this case, or at least not as with simple values, because what it does is it condenses lists into one list. So if I now do this, and then I look at the output, I get a really long list that contains all of this stuff in one list. To get around this, what we need to do is we need to use the list as item node. One for here. What that does is it keeps the list as single items. They're still lists, but combine will not condense them any longer. So list as item. There you go. And now if we select these and we say combine, and then if we say list, now we have a list of 3 lists, each one having 5 items. Let's change this just for kicks, where we'll say 9 and like 10. All right. So we have 3 lists, 5, 9, and 10 items. And now we can select them as lists. So let's say select and list. And now as we change the index, we get a different list. The last thing about lists for this video is we need to talk about tables. Tables are also lists, but they're lists of lists. This was the easiest way that I found to implement them. Let me grab some CSV data. This will be the easiest to show. Again, CSV is something I'll talk about in a separate video. So we will create a text node, paste it in, align left. All right. Then what we're going to do is we're going to say data parse CSV. This is wrong because it gives us 1 column and 14 rows, but it's clearly more. That's because this is separated by semicolons and this uses a comma, so we'll replace that with a semicolon. And there you go. Now it's 9 columns and 14 rows. And so if we now say list, and we have to connect it like this from here. What we get is 14 rows, each one of which contains 9 items. And we can see what's inside each of these lists by using a list node, like so. So each one of these is a row. But we're not going to connect, a list to each item to see what's inside. Here again, we can use the select node. So what we do is we take this, we say select. We don't have to connect it to this, we can connect it directly to here, but here we can see what it is. And then now we say list. And so now as we change the index, we get a different row every time. So this is the way to access rows of data. We can also look at columns separately. So let's just put this over and we can just delete this. If we say column, once again, it's the same. Then we add a list to see what's inside. And now we see that this is the column of car names. In this case, we don't really want to have the title and the type of column because as we change the index, you see that it changes. It's not the data that we need. So here, before these 2 nodes, we can insert a sublist. And we can set the starting index to 2, which then filters out the beginning. And now we can just look at the column data without the title and the type. And of course, because it's a table, you can access a cell directly by just specifying the column and the row. But here the output is a single wire because you're just getting 1 single value. To see what it is, we can use a text node. Let's just delete all this. There you go. And so now as you change these indices, you basically travel up and down the table and left and right. And you get access to each individual cell. So that's it for this video. In the next one, we'll talk about sorting and filtering lists.